area of a semicircle inscribed in a quadrilateral. What we're going to do here is work out the area of a semicircle inscribed in this quadrilateral. We're trying to find this shaded region. So let's get a bit of visual aid as we go along. Here we go. Just going to stop it there for a second. Let's read what we have to do first. In the diagram, side AD of quadrilateral ABCD is tangent to semicircle O with diameter BC. Side AD there is tangent to the semicircle, which is here, with center O here and a diameter BC, diameter of 40 centimeters. Question A. Determine the total area of the shaded regions, colored regions. This is the blue section here and here. We need to determine this colored section here. Section B. Question B. Determine the angle AOD. Angle AOD. The angle that's made at the center of the circle between AOD. So let's do this in stages first. The area of the shaded region equals area of trapezium minus the area of semicircle. The quadrilateral ABCD, if we rotate it counterclockwise 90 degrees here on the right hand side, we see the quadrilateral as a more familiar trapezium. However, seeing it as it is there might not be so straightforward. But if you rotate it counterclockwise by 90 degrees, you can see it as a familiar trapezium shape. So let's use that property and it's how to work out its area in order to get the area of this quadrilateral. The area of the trapezium equals half times A plus B multiplied by the height. We have our A as 16 centimeters, B as 25 centimeters there, A, B, and 40 centimeters is our height of the trapezium there. So the area of the trapezium works out to be 820 centimeters squared. The area of the semicircle inscribed inside this trapezium or the quadrilateral is half times pi multiplied by r squared. Now the area, we're taking the radius of our semicircle to be 20, which is half of the 40 centimeter diameter BC. So our radius is 20 centimeters, and this, the area of the semicircle, works out to be 200 pi centimeters squared. Now the area of the shaded region, this is the blue region there within the quadrilateral, is 820, which is our quadrilateral's area, minus 200 pi, which is our semicircle area, which equates to 191.68147 centimeters squared, the area of our shaded region. That's our section A done. In section B, determine angle AOD. Let's move on. What we'll see here, I'm just going to pause that for a second. Determine our angle AOD. I've put in a line from A to the center of the circle O, and another line from there to the center to D. The angle that we're looking for is the angle made by these two lines in between, which is our O, angle O. In order to do that, we need to work out the angle A and the angle B and subtract it from 180 degrees. Angles on a straight line add up to 180 degrees there. So our semicircle, as we know, is 180 degrees in the center out of 360. So once we know that property, we can determine our angle A. angle O. So let's work out angle A first. Basic trigonometry, tan theta equals opposite over adjacent, therefore theta equals inverse tan or of opposite over adjacent. So let's work this out. Arctangent of opposite over adjacent. What we have is opposite being opposite of our angle A is 16 centimeters. Adjacent to our angle A is 20 centimeters, which is our radius of the circle. So 16 upon 20, we work the angle A out to be 38.65981 degrees. I've kept this accuracy for the time being in degrees. So when we add it together with our angle B, we should have a more accurate version of what the angle A and B is as we subtract it from 180 degrees. Angle B, again, opposite is 25 centimeters upon 20 centimeters, which is our radius of the circle, semicircle. So 25 upon 20, and arctangent of that value will come to 51.34019 degrees. Now our angle O between the angle A and B, that's this bit here, which is the bit we're looking for, equals 180 degrees minus angle A minus angle B that we've already worked out above. Now that equates to 90 degrees. So our angle O is 90 degrees. The angle that we're determining between A, O and D, this angle here, is 90 degrees. That's the angle we're working out. So have a look at it yourself. If you do like this, please click like on YouTube and Facebook and Google Plus One it. You can download the Shockwave Flash file from the website link below this video. Okay, thanks.